Myself, Mariappan Subramanian. I'm a senior software engineer at Freshworks. At Freshworks, I work for Freshworks Marketplace. It's part of developer platform team at Freshworks. So today, I'm here to talk about streaming server-side rendering simplified with Next.JS. So before diving into the topic, let me just quickly skim through the agenda. So basically, we'll start with a quick warm-up of rendering fundamentals. I assure you I will not bore with the intro again. We'll just skim through it. And then we'll understand the limitations of current SSR architecture we have. And I'll touch upon suspense SSR architecture of React 18. And we'll also get introduced to loading UI and streaming mechanism that came packed with app router of Next 13 new version. Then we'll see a lightweight demo of the same. And finally, wrap it up by understanding how it actually helps in real-world application development. When I say rendering, right, basically I write a piece of code and it gets rendered on the screen. So broadly, it can happen in two environments, like server and the client. So if you take any traditional SPAs, React SPAs today, it's probably like client-side rendered. So all I do is like I request page to the server, okay? Server responds with HTML, which include a script tag, which basically then my client will be browser will be downloading the JavaScript record for that, okay? And then the React comes into play. I hope you might have heard about hydration. So basically, it will try to attach some event listeners and other stuffs to make the application interactive. And finally, I get to see a fully visible interactive screen, okay? So these are some like high-level 4 stages that is happening. This is fine, but the issue here is like, if you see these stages, right, only at the 4th stage, I get to see anything on the screen. So in all these 3 stages, what I see is a simple loader or a blank screen. Okay? So this is definitely not a welcoming experience. So how do we solve this? So server-side rendering came into picture. So like, let me take a persona. Emma is the persona here. So she is requesting the same page to the server. Okay. This time my server is doing something different. It basically tries to load all the data required. Okay. And then it tries to build the markup on the server end itself. Okay. And then it sends back that markup, which has a script tag, which will basically hydrate the app and make it interactive. If you compare this and the before slide, these are the 4 stages which happened in earlier slide as well. But here the difference is the major heavy lifting is taken care by the server. Okay? So we basically tell, hey, this browser is not meant to do all these stuffs. You are capable of doing it better, and you can do it much faster as well. So we'll leave the job to the server end. Okay? So this is how SSR became popular. And why it's a big deal? Why server has to do all those and give us, basically, the initial loading time will be reduced drastically, and you'll get many other advantages like this, right? So there came like lots of adoption. That's why the meta frameworks like Next.js became popular. If you consider the key performance indicators like time to first byte, or first contentful paint, or time to become interactive. So these are some basic metrics any web developer would be concerned about, right? So like these 4 indicators are just the previous 4 stages. So if you look at these things, right, this happens one by one. These steps are basically highly sequential and blocking, okay? So I can't proceed to the next step until the first one is completed, okay? So basically, like if I narrow down, the actual problem is this. You have to fetch all the data before you can show anything on the screen. And you have to load everything before you can hydrate anything. And you have to hydrate everything before you can actually interact with anything. Okay? So here the actual issue is the everything here. So I can't do anything in parallel. So these are highly sequential and blocking, right? So consider a heavy data intensive application. This is going to be a concern. So how do we solve this? Let me switch the context. Let's forget all the technical jargons. Okay, let's talk about some. Let's have a break. Like, you all know appetizers, right? So let's say I'm taking you all to a restaurant, okay, and there's a high possibility you start your meal or your lunch with an appetizer at the start, right? And likewise, the restaurant or the waiter could possibly offer you or propose you an appetizer menu at the start. So it's for various reasons, but if I have to pinpoint, basically, as the name indicates, right, appetite. So it, it kind of curbs the hunger, it sets a vibe, okay? It basically sets a mood to begin. It's the kind of experience that restaurants strive to provide, okay? And this hierarchy continues. Like, let's say there are a few children with me, I'll possibly try to bring those dishes which were, those children were interested at first, right? So, because I can't convince them. And likely restaurants also will love to offer that. And say, let's say I have 4 or 5 dishes, okay? I can showcase my interest and the waiter can prioritize which I'm interested in and deliver it first, right? So this is kind of prioritization that will happen in any dining experience, okay? So why I'm talking about all this is that this kinds of, this is the same. If you apply this same paradigm, if we can do this same in real-world application development, it kind of solves lots of problems. It gives a pleasant or favorable experience to the user. Okay, let's see how it is. So this is what the new suspense SSR architecture of React 18 is also trying to provide. So basically, when I say suspense, right? So suspense is not something which is very new to React. It's been there since 2018. But earlier suspense is like you'll have that. It's basically a loader before. You'll have that component at the DOM. You'll just hide it, like keep it hidden, and show it whenever required. Okay, that's not a magic at all. But with the new React 18, right, you got some, the word concurrency comes into play, and you got concurrent rendering engine. So which basically does 2 amazing jobs. One is streaming HTML. When I say streaming, like it's like streaming, right? Like progressively rendering. So it can stream, like that's made possible with a new API called render to pipeable stream. And you also can do selective hydration with suspense. I'll come into these terms in upcoming slides. So basically, let's say you have a component which does a async action that will take some time. What you do is, all you have to do is like wrap it to the suspense boundary, and possibly you can have an error boundary too. Consider a promise. It's a promise basically. So this promise, when this promise is executing, right, it will hit the suspense boundary, will like render a loading component, okay? And let's say the the promise rejects or some API failure or something, it will hit the error boundary. So this is a high-level thing what suspense is about. Actually, this can be a separate topic itself. I will not get into the details. Instead, I have left some links here. There's a detailed post on the same from Dan Abramam. You can read about the entire architecture. And this link will particularly take you to the implementation of it. But let me move to the actual abstracted part, which I'm trying to showcase. So before getting into this, how many of you have already worked with Next.js or Next.js kind of frameworks? Okay, cool. So when we have such powerful thing like React or Vue in place, why do you think meta frameworks like Next or Next has such huge adoption? Yeah, like anyone? Why such frameworks, meta frameworks are becoming highly popular? Yeah, server-side rendering is one reason. So basically, there is a very fundamental thing. These meta frameworks simplifies a lot. Like it provides an attractive advantage of high-level abstraction. Like you don't have to do a lot of things. It basically simplifies all the complicated stuffs and give you something which is very easy and quick to start with. Okay, so to incorporate that React 18 features, right? Like Next came with a new release, Next 13, which is, I can term it as app router. So that app router has enabled many possibilities, and one such thing is incorporating suspense in it. So it's basically like, all you have to do is create a loading component. I'm naming it as loading.js. You can name it anything. And wrap the async action or like your child components, which would take some time, with a suspense boundary. And yeah, with a suspense boundary, and that's all you have to do. Okay. It greatly abstracts. Like it comes with built-in suspense support. It enables code splitting. And like with app router, right, data fetching is possible. In case of React, what you have to do is the same thing, but still you have to use something like get server-side props or like many other APIs to make all these possible. But with new app router of Next, right, everything comes inbuilt. You can straight away implement. You will never realize you are doing something like suspending behind. Okay, and it has out-of-box support for SEO, and it has a great support for. It's compatible on both Node and Edge runtimes. So I'll show you a very lightweight demo of it. So basically, this is just a simple blog page, okay, which has some text over here, and there is a gallery component which basically hits an API, gets some data, and this is rendered, okay. And we have a comments or review section which fetches some data from an API, okay. So if I reload this, right, what happens is there is a loader, gallery gets loaded, and then it takes some time and customer. So now you can ask me, is it a simple loader? Not exactly. I'll tell you why. So basically, the code will be like this. Like I have some text, and then I have a gallery component which is wrapped in a suspense with a gallery loaded in place, and I have a comments component which wrapped in another loader, right? So it's that simple. All I have to do is this. Okay, I create a loading component and wrap it to the suspense. Okay, and if you look at here, like this basically for the demo purpose, I have simulated with set time mode, but this is not something you have to. It's basically a promise, and you can use the ordinary fetch to fetch data. This is a server component, and you will like I'll not get into more time. So what's happening behind is that you basically when you wrap it in a suspense, right, the generated HTML will look something like this. All you see is the loader in place. You will not have that comments component even. Okay. Later, what happens once that comment is ready, right? It gets transferred as a chunk. This is a low-level representation, but this is not the exact code. But something like this you will get something like this. You will get a script tag which will tell where exactly this component has to be fitted in, right? So I'll give you one other reason why this is not a simple loader. So actually, these things are not possible earlier. Like I can actually interact with the page before iteration. If you look at this infographic here, right? Imagine this fourth section is the comments section. It's getting loaded, then I get to see the page, and React starts hydrating. While let's say the comment section is taking some time to hydrate, I can actually interact with other components. This is made possible. And similarly, selective hydration. Basically, let's say these two sections are getting some time to hydrate. Okay. Meanwhile, I try to interact with the comments section. Now, React understands the user is basically interested on this part, so it stops the job there. It comes here, hydrate this, and then continue this. So this happens in a batch. Like I have this is a detailed algorithm, but in a high level, this is something like this. It just checks if it has more component, and if it doesn't have any other important stuff to do, it renders it. Otherwise, it just focuses on the important stuff to do. So you can just think of this has other important stuff to do as a flag, which React keeps toggling. And based on that, it will decide on which one to hydrate first or which one to process first. So how it actually helps is, if you compare this one with the earlier diagram, so all you get to see is like, let's say there are three components, A, B, C. When the data for the A component is ready, right, it immediately starts rendering on the HTML. Okay, and let's say that's also quick. It immediately start hydrating. All these steps are not sequential. It's happening in batches in parallel. So if you look at these metrics, got shifted way ahead. So how it matters? Actually, Google tags if an application has a FCP less than 2 seconds, it's something appreciable. Similarly, for time to interactive, it's 3.8 seconds. Imagine a data-intensive application like e-commerce application or something. This factors a lot. These factors are means a lot, right? So this way of batch-wise execution in parallel helps a lot in that. So these are some references which I have used. You can, I wish I could go through the code but due to, this is a lightning talk, right? This can be a good starter. You can go through these references and ask me any questions.
Thank you, Mariappan. That was a very insightful talk.